Welcome everyone. In this video we're going to go over a 14.6 exam problem. In this case we're back in fall 2015. I found a problem that I like a lot. Question number 6 here. First we're going to find the gradient of our function f at a specified point, and then we're going to do a directional derivative. So the derivative of f at this point in this direction, the direction of a in this case. So okay, let's go ahead and first find our gradient. So remember the gradient here, we have x's, y's, and z's. So this is going to be the partial derivative with respect to x, the partial derivative with respect to y, the partial derivative with respect to z as our three components of our vector here. So let's go ahead, take the partial derivative with respect to x. Well, okay, it looks like we have a product rule, right? There's a couple x's here. So I'm going to take the derivative of the first times the second plus the first times the derivative of the second. And the second part here, this yz squared, this doesn't have any x's, so that just goes to 0. Derivative with respect to y, I'm going to get a nice even z squared here. Again, this bit only has x's in it. And then you take the derivative with respect to y. Remember, z is constant, so we just get whatever that constant is. And then finally, if I take the derivative with respect to z, I believe I should get 2yz. So again, x and y are constant. They're along for the ride. So when I take the derivative of z squared, that's where the 2 comes down there. Okay, and now I'm interested in the specified point. So again, this is my gradient vector. I want the gradient vector at p, or I guess p sub 0 in this case. That is, x is 0, y is 2, z is -3. So x is 0. Looks like I have e to the 0. That's going to be 1 plus 0. Let's see, z squared. So that's going to be -3 squared. That's 9. And then 2 times y times z. So that's going to be 2 times -3. I hope that's -12 altogether. So I get the vector 1, 9, -12. All right. For part B, I would like to find the derivative of this function at our point, p sub 0, in a specified direction, in the direction of a. All right, so the idea here, right, so again, I'm taking a directional derivative, so the direction, in the direction of a, of f. So this was the notation that we brought up in class. So d sub a of f, the direction in the a direction with our function f. And so remember, this is going to be the gradient here, 1, 9, -12 at our point. And then we're going to dot it with a. So that's going to be 2, -1, 2. But the only thing here is that this needs to be a unit vector. So because a is not a unit vector, let's go ahead and divide by its magnitude to make it a unit vector. So 2 squared is 4, -1 squared is 1, 2 squared is 4. There we go. And so we're going to have, let's see, 2 minus 9 minus 24, and then 1 divided by root 9, so that's going to be 1/3 altogether. So 2 minus 9 minus 24, so I'm thinking 7 and 24, that's 31. So let's see, this is going to be -31 divided by 3. So we could also get like an interpret your answer sort of deal, right? So if you take a tiny step in this direction of a, the idea is that we are decreasing by around 10, right? So this 30/3 would be around 10. So this is quite the decrease there. All right, so there is our two-parter, right? This again was a 14.6 problem. We talked about gradients, we talked about directional derivatives, all this sort of stuff. There you are. I'll see you guys next time.